Ever wondered about the hidden wonders of our planet? Welcome to Zoolara. Today, we're diving deep into the mysterious world of a creature that dances between worlds. Not just the world of shallow reefs and open ocean, but also the world between the surface and the crushing depths. This is the realm of the Mobula ray, a family of animals so incredible, so unique, they truly redefine what we think we know about life in the sea. These are not your average fish. They're masters of the ocean ballet, architects of their own watery world, and the giant manta ray well, it's the pinnacle of this incredible lineage. Out of 600 plus ray species, only 11 belong to the Mobula family. They all sport this distinctive diamond-shaped body, wings that allow them to soar through the water. But the real star here is the giant oceanic manta ray Mobula Birostris. Its wingspan can reach a staggering 8 meters or more. Imagine that. A creature wider than some cars are long, moving through the water with grace that defies its colossal size. These giants are more than just big. They are curious, social, and incredibly intelligent. And when I say intelligent, I mean it. Manta rays boast the largest brains of any fish, with a brain-to-body ratio that rivals even the mighty whale shark. This intelligence isn't just a curious footnote, it's central to how they live, how they interact, and how they explore the vastness of their ocean home. For the longest time, we didn't even know where to place these magnificent creatures on the tree of life. Scientists originally grouped giant and reef manta rays under the same genus. But deeper dives into their genetics and morphology revealed that these gentle giants actually belong to a different genus altogether. Mobula, alongside the smaller devil rays. It turns out, this reclassification was just the start of unraveling what we thought we knew about these animals. We'd pigeonholed them as shallow water plankton eaters, but the truth is, they're so much more. They're deep sea renegades, their movements so fluid and efficient that roboticists around the world are trying to learn from them. And they're not just diving a little bit deeper. We're talking dives that push past 1,000 meters into the midnight zone, a place of crushing pressure and near total darkness. This is a game changer. Then there's this. They've been observed rapidly changing the color and pattern of their skin, something unheard of in the world of elasmobranchs. So many questions remain, from why did they evolve to be so huge, to how does a massive body move so efficiently, and what's with this incredible color-changing ability? Let's talk about those wings, because they are the key to everything. When rays diverged from sharks 200 million years ago, their pectoral fins morphed into these vast, flexible structures. In the giant manta, this expansion is nothing short of extreme. These wings, that make up 85% of the body length, aren't just bigger, they are way more dynamic than any shark's pectoral fins. Think of a shark. Fast in bursts, but pretty limited in maneuverability. Now look at a manta. They're acrobatic, turning on a dime, circling back to feed, evading predators with an agility that seems to defy their size. It's all thanks to those large, incredibly flexible wings. While their overall wing shape might resemble that of a bird, manta ray fins can undulate and bend in way more ways than any bird wing could dream of. Inside, there's a network of structures that can be controlled separately, giving these giants a level of control, agility, and precision that we're only just starting to grasp. It's like having a pair of high-performance, morphing hydrofoils. But all this maneuverability comes at a cost. It means controlled instability. Without stability, you can't swim smoothly and efficiently. Luckily, the manta has struck a perfect balance. They achieve stability with their high aspect ratio. This means that manta wings are narrow and long, helping them stay balanced during flight, kind of like a tightrope walker using a pole. Longer, narrower wings help generate lift efficiently. But it's not just about the wing's shape, it's about how they move. Manta rays combine fin oscillations and undulations to move effortlessly through the water. Oscillations are the flapping, up and down motion, generating both propulsive force and lift. And then they've got these undulations, a wave-like motion traveling from their body towards the wingtips. These two movements work in tandem, creating these underwater vortices, pushing against the surrounding water, propelling the manta forward with insane efficiency. Scientists have measured a propulsive efficiency of around 89% for these giants. That's a level of hydrodynamic mastery that puts most man-made vessels to shame. To understand more, manta rays have to keep swimming to breathe. They're designed to swim. You never see one resting on the bottom. And they have this pointy diamond-shaped body structure where stingrays are round, so they can get a lot more power out of their wingtips. Based on their pancake-like shape and their flapping wings, it might be tempting to see them as a bigger version of a stingray. True, they belong to the same class of cartilaginous fish, but they are fundamentally different animals. Unlike stingrays, mantas have mouths on the front of their bodies rather than underneath, and they have these amazing cephalic lobes, two fin-like appendages that funnel water and plankton straight into their mouths. In fact, these lobes make mantas the only vertebrate with 6 paired appendages instead of 4. But unlike stingrays, mantas don't have the long venomous stingers. They have lost their ability to sting, and that's just the start of the differences. Look at their teeth. Stingrays have crushing plates, used to crack open shells. Manta rays have tiny peg-like teeth on their lower jaw, mostly used during mating. They're not made for chewing. They're filter feeders. They open their mouths and swim into swarms of plankton, collecting their meal with giant flying colanders. The shift from crushing teeth to filter feeding goes back millions of years to a time, maybe after dinosaurs went extinct and there was a boom in plankton. This shift allowed them to evolve into the ocean giants we see today. And here's the kicker. How did a diet of tiny plankton push them to become so big? We often think of size based on the food chain. Big predators eat big prey. But it turns out it's not about the food chain, but the quality and abundance of food and the animal's ability to exploit it. In biology, it's called Cope's rule. Over time, evolutionary lineages tend to increase in size, and for good reason. Being bigger can improve survival. Think of it. For apex predators, there is only so big you can get. But for plankton eaters, bigger is almost always better. Massive size increases their foraging range, greater energy stores, a larger mouth, and surface area to process more water, and of course, less likely to be eaten. When they are full grown, they have very few predators. Really just orcas. But this all comes with a cost. Orcas will take a shot at them, and even sharks will try to take a chunk out of the back, but typically they survive it. But sadly, history has shown us, large animals are more at risk of extinction. They need more resources and their reproduction rates are slow. Organisms with quick reproductive cycles are much better adapted to changes than slow-growing, slow-reproducing creatures. Manta rays get big, and they have a long gestation time. That's 1 year, with females only giving birth every few years. It's more similar to an elephant than a regular fish. They put all their eggs in one basket, and so have a higher survival rate, but their slowness and size makes them susceptible. For a long time, we thought the shallow water story was the whole story. We'd see them swimming with their mouths open, filtering out the tiny plankton, and thought that was it. But that was far from the end of the story. We know now that these ocean wanderers sometimes plunge to incredible depths, all the way to the midnight zone. For decades, studying mantas has been a real challenge. They travel vast distances, and our encounters have often been limited to brief shallow water glimpses. It took a lot of dedicated research, like in Ecuador, where they collected small samples of tissue from these gentle giants and compared it with plankton. When they analyzed nitrogen and carbon isotopes, it became clear that what they were eating wasn't just surface plankton. They were eating things from the mesopelagic zone. With satellite tags, they saw just how deep these rays go. One group found manta rays diving down to depths of 1,400 meters. Another group found that they tend to stay closer to the surface during the day, maybe to warm up, but then plunge deep at night. For the longest time, we thought that these were intrepid travelers, going all over the place, searching for food. And sometimes that is true. They can migrate long distances. But then, we learned that some manta populations stick close to home, rarely going beyond 150 miles from where they were tagged. They are not all migratory, and they tend to eat food specific to the region, perhaps because of food abundance. But even with all that, we've learned there's still so much that we don't know. Like, how is it that these animals can change the color of their skin? Manta rays are generally described as having this chevron pattern, a dark back with two white triangular patches across the head. And their bellies are white, with some dark patterns. But what if I told you the coloration changes? Researchers were surprised to see the skin around their eyes, mouths, the inside of their cephalic fins, and the chevron rapidly change color. They'll lighten or darken during social interactions or when they're about to be fed. Why do they do this? Well, we are not sure, but they have great visual abilities and large brains, so it's probably related to social behavior. It's a fascinating insight into a complexity we didn't even know existed. And it gets even more wild. They even seem to have a level of self-awareness. They tend to perform more repetitive actions in front of a mirror. What does this all mean? It is very hard to quantify intelligence in animals, especially in these gentle giants. But one thing is for sure, they have the biggest brains of any fish. In fact, their telencephalon associated with memory, learning, and social behavior accounts for 61% of their total brain mass. And they're not just big brains on a big body. They're big brains for their body size, and that means mantas are probably very intelligent. Their sophisticated social lives support this, and their interactions with humans just make you wonder. But while they're extraordinary, they are increasingly vulnerable. Because they feed on plankton, they ingest lots of microplastics. They're caught by every type of fishing and are often hit by boats. Also, falsely believing manta gill plates have health benefits, they are killed for those parts alone. Despite all this, researchers around the world are fighting to learn about them and protect them. This year, the giant manta was listed as threatened under the U.S. Endangered Species Act. The more we learn, the better we are at ensuring our actions don't hurt them, and the more chances we have to encounter these incredible creatures in the future. Thank you for joining us on this incredible journey. If you found this video fascinating, please like, share, and subscribe. Your support allows us to keep bringing you amazing stories like this one. Don't forget to check out our Patreon and see more of these incredible creatures in the links below.